So now that we talked about probability and we talked about some of these other concepts with data, what we're going to move into is a concept called expected value, and that also ties in with weighted grades. So to begin, the expected value or commonly referred to as just the expectation, is often used to determine the expected results of an experiment or business venture over the long term. So we have this concept of what's considered normal. Now we're trying to lead into a concept to see what do we expect to happen. But the idea is this has to happen when you repeatedly do the same thing over and over and over again. So over a long-term venture, what would happen? So what I'm going to do is I'm going to look at this through an example and we're going to build to that concept. So suppose I make a bet to you. We're going to roll a die a bunch of times. So we'll say we'll roll it 1,000 plus times. So that die has the possibility of the numbers 1 through 6 on it. If the number is even, I'm going to give you $1. If the number is odd, you give me $1. So every single roll, we're going to play this exact game. I give you $1 for an even number, you give me 1 for an odd number. And if we want to think who would win money in the long run, we have to think about the probability of getting an even versus getting an odd. So if you think about that, your dice has 6 options. 3 are even, 3 are odd. So I would expect it to be a 50-50 chance of one of us winning. So half the time I would expect to pay you $1. The other half I would expect you to pay me. So half the time I would expect to pay you $1. The other half I would expect you to pay me. So if it's this kind of constant back and forth, half the time I'm giving you $1, the other half you're just giving it right back to me, I would think we would break even. If I only did this 4 times, then yeah, there's a chance that every single time I could pay you $1. But if I'm doing this a large number of times, so we're playing this game 1,000 times, I'm going to expect that it's pretty close to 50-50. So why is this actually the case? Why does it make sense that we would break even? So this is where we're going to build into the formula for expectation. So our expected gain or loss is going to be broken into 2 different pieces. There's 2 possible outcomes. Either I lose money or I win money. So we're going to look at the probability that I lose, and we're going to look at the probability that I win. So these are the 2 possible outcomes. What I'm going to do for each of these is I'm going to multiply the probability I lose by the amount of money I would lose. And then if I win, I'm going to multiply that by the amount of money I win. So in this case, the probability I lose is going to be if the number is even, well, there is a 1/2 or a 3 in 6 chance I lose. And in that case, I'm going to lose $1, so I am down -$1. If I add to that the probability I win, well, there is a 3 in 6 chance that I win. And the amount of money I would get in those instances is $1. So if I multiply these out, 3/6 is really a half or 0.5. So if I times that by -1, this is -50 cents. And then 3/6 is a half times $1, that's +50 cents. So if I add these two together, they cancel out, and I would expect to net no money by playing this game a large number of times, okay? So this is exactly what we're going to do with expectations. We're going to look at all of the potential outcomes, and we're going to find the probability for each of them. Then we multiply it by the amount you lose or win in that particular event, okay? Could be typically money, that's what we expect, or some other amount. It just depends on the type of problem you're working with. So ultimately, our formula for expected value is we denote it with an E. You take the probability of event 1 happening, and you times that by the amount of money or amount of whatever you win or lose if that event occurs, okay? So P1 is the probability of event 1 occurring. And A1 is going to be the net amount you win or lose. If event 1 occurs. And then you're going to add the same thing with the second event, whatever its probability is, times the amount you win or lose. If it's lose, it's a negative amount. And then you do this for however many possible events there are. So we don't have an end, we indicate that with n, the nth event. So it could be there's only 2, like in the last example. There could be 5 possible outcomes. And in that case, you would have to do 5 of these probability times the amount, okay? So let's try some examples of this. For the first one, in a proposed business venture, Stephanie estimates there's a 60% chance she'll make $80,000 and a 40% chance she will lose $20,000. We want to determine her expected value. So there are 2 different cases here. We're either going to make money or we're going to lose money. So there is a 60% chance of making 80K. And then there is a 40% chance of losing $20,000. So those are the only 2 possible outcomes. So our expectation is broken based off that. We want to find the probability that she makes money. And we're going to multiply that by the amount she's going to make. Then there is a chance she loses money. So we're going to find that probability and multiply it by the amount she loses. So she tells us that she's estimating there is a 60% chance she's going to make money. So that is our probability. As a decimal, that would be 0.60. Okay, because again, there is a 60% chance she makes money. The amount of money she's going to make would be $80,000. So we're going to times that by 80,000. Then we have to do this with the other possibility, and we want to look at the probability she loses money. Well, that's a 40% chance. So as a decimal, that's 0.4. And the amount of money she loses is $20,000. But you do have to be careful. You don't want to times this by positive 20,000. She is going to lose money. So I need to make this a loss. So we have to put that minus sign. Okay. Then from here, I need to figure out and plug these into the calculator. So typing in those pieces, we need to take 0.60 and we need to times that by 80,000. and then we are going to subtract ultimately, but I'll kind of take this piece by piece. When you multiply these two together, it gives you 48,000. And then if we do 0.40 and we times that by negative 20,000, that gives us negative 8,000. So subtracting those two, we would expect to gain $40,000. Okay. And so again, it's a little bit hard because this is only one we're doing a business venture this once, but if she were to continue to make business ventures of the same idea, then on average, we would expect her to make $40,000. There'll be times when she makes money and times when she loses money just because of that chance. Okay. So let's try another example of this. At the Royal Dragon restaurant, a slip in the fortune cookies indicates a dollar amount that will be subtracted from your bill. A bag of 10 fortune cookies is given to you, from which you will select one. If 7 cookies contain $1 off, 2 cookies contain $2 off, and 1 contains $5 off, we want to determine the expected value of money off of your bill. Okay. So here we have 3 possible outcomes. So essentially, if I were to go to this restaurant over a long period of time, this would be my expected value every single time I go off my bill. So I have 3 outcomes. So my expectation is going to be written into 3 different pieces. The first one is we can receive $1 off. The second is we could receive $2 off. And the third event is we get that extra fortune cookie, extra special one, which gives you $5 off. So I have to take the probability of getting $1 off, and we're going to times that by the amount of money we would get off. Okay. You can say, because this is giving you money back, you could say it's negative, but really, since this case, all of them are the same, you're not going to pay extra. We can just times this by $1. Then for the second event, we need to see what is the probability of getting $2 off, and the amount of money that we would receive off in that case is exactly $2. And then in the third event, we want to see what's the probability of getting $5 off, and the amount of money we would get off would be exactly $5. So I have to go through and I have to calculate each of these probabilities. So I have 10 fortune cookies in total. So my denominator is going to be out of 10. If I look at $1 off, there are 7 cookies that contain $1 off. So our probability is going to be 7 out of those 10 cookies. Okay. And then we times this by $1. For the probability of getting $2 off, it's still out of 10 cookies, but there are 2 out of 10 cookies containing a $2 off coupon. So our probability is 2 out of 10, and then we times that by $2. Then last but not least, we have the probability of $5 off, and in this case, there is 1 cookie that contains $5 off. So our probability is 1 out of 10, and then we times that by $5. The thing to kind of recognize, 7 plus 2 is 9, plus 1 is 10. These 3 probabilities count for 100% of the possible outcomes. So from here, it's a matter of multiplying these. So I'm going to trust that you could plug this into your calculator. 7 divided by 10 is really 0.7. So when you times that by $1, this will give you 0.70. 2 over 10 is 0.2. timesing that by 2 would give you 0.40. And then 1 over 10 is going to be 0.1, times that by 5, and you would get 0.50. So adding these together gives you an expected value of receiving $1.60 off of your bill. Okay. So we're going to try one more of these, and then we'll talk about weighted grades as well. So in this case, assume you spin the pointer on the following wheel and you win the amount of money that's indicated. In order to play this, if you're at some fair or something, you have to pay $2 to actually play the game. We want to figure out what is our expected value. So in this case, because we have a lot going on, I'm going to actually make a little chart as to what's happening. So here is our spinner. We're going to look at all of the different events, the probability for each of them, and then we'll figure out what that net gain or loss is. So in this case, my spinners kind of split up a little bit awkwardly, but what we can actually do is we can just extend these lines and cut them in half. So in this case, we ultimately have 1, 2, 3, 4, 5, 6, 7, 8 slices. And then I'm going to go ahead and I'm going to make these dotted just so I can keep track of what those slices were. So in this case, I have 3 possible outcomes. The first is I get $1. So that would be this slice, and then it would correspond to these 2 slices as well. So my event would be I land on $1. Then if I look at my $10 slice, I have this one here. And then I have a bigger slice, which counts for 2 of the 8 slices. So my other event would be I land on the $10. And then last but not least, I have my $5 slice, which is right here. And that is my last possible event. I land on $5. You could definitely reorder these to put them in increasing and decreasing value. Doesn't really matter though. Okay. So if I calculate the probability for each of these, again, I've got 1, 2, 3, 4, 5, 6, 7, 8 equal slices. So this slice is 1/8. This would be 1/8 and 1/8, or 2/8. This here is 1/8. This slice is an 1/8, and same thing here. And then likewise up here, you have 2 slices that are 1/8 each. So if I consider landing on $1, there is 1, 2, 3 out of 8 slices. That would give me $1. So my probability of getting $1 is 3 out of 8. My probability of getting $5, there's 1, 2 out of 8 slices, which would give me $5. And then for $10, there is 1, 2, 3 out of 8 slices that give us $10. And if I go ahead and add these together, 3 plus 2 is 5, plus 3 more is 8, accounting for 100% of my probability. Okay. Now I want to look at the net gain and loss in each of these situations. In the first case, I land on $1, so they give me $1. However, it cost me $2 to play the game. So I'm getting $1, but I've paid $2. So really, I would lose $1 if I land on this slice. If I land on $5, they'll give you a $5 bill, but you already gave them $2. So really, you're only walking away with 3. And then if you land on $10, they will hand you a 10, but again, you paid $2. So you are actually only going to get $8 as a gain, okay? So these are all of my outcomes. I now can go ahead and calculate my expectation. So it is the probability that we land on $1 times that net gain from here, or loss in this case. Then we add to that the probability we land on the $5 slice and multiply that by the net gain. And then we do the probability of landing on the $10 slice multiplied by that net gain. So our probability of getting $1 is 3/8. And in this case, we would lose $1. Our probability of landing on 5 is 2/8. And here we would gain $3. And then our probability of getting $10 is 3/8. And our net gain is $8. So again, you can make these charts and you just take the probability and times it by that net gain or loss. The probability times the net gain or loss. The probability times the net gain or loss. And then from here, we just plug it into a calculator. So bringing up Desmos, we've got 3 divided by 8, and then we want to times that by -1. We want to add to this 2 divided by 8, and we're going to times that by 3, and then add to that 3 divided by 8 times 8. And so we get that total. It gives us 3.375. We're working with money though, so it just makes sense to round to the nearest penny. So if we played this game over and over and over and over again, we would expect to win $3.38 on average, which really doesn't seem like it's smart on their part. We don't want to win. If you go to a casino, it's always the casino that's going to make money, not you, if you continually play that game. But we would expect to win $3.38 by playing this. So this leads into the idea of a weighted grade because it's kind of calculated in a very similar manner. Instead of having probabilities and net losses and gains, you really have different categories and then your averages in those categories. So essentially your averages are going to take over the probability, and then it's multiplied by the weight in that particular category. Okay? So a weighted grade uses a scale to assign some categories a bigger portion of overall grades than the others. So if you think about how most of your grades are calculated in all of your courses, you have different components like homeworks, exams, essays, your final, projects, whatever it may be. And certain categories are worth more than others. Same thing when it comes into finding your GPA. If you take a 5-credit class versus a 3-credit class, the 5-credit class has more impact in your overall GPA than the 3-credit. Just like a lab being 1 credit doesn't have as much weight as a 3-credit course either. So all of those have to be factored in when you're calculating the overall score. So we're going to consider the following grading scale. Your homework is worth 15%, your exams are worth 60%, and your final is worth 25%. So let's take a look at one particular student. If one student earns 140 out of 210 points on their homework, a 64 out of 100 points on exam 1, 80 out of 100 points on exam 2, 77 out of 100 points on exam 3, 42 out of 100 points on exam 4, 73 out of 100 points on exam 5, and then 65 out of 100 points on the final, we want to figure out what their weighted grade is, and we are going to end up rounding to 1 decimal. Okay. So there's a lot going on, but this is what happens every semester in most of your courses. So our homework grade is out of 210 points and you earned 140. This will only count for 15% of your score. Then we took 1, 2, 3, 4, 5 exams, got a grade on each of them. Their average is going to count for 60% of your overall grade. And then this final exam will count for 25%. So what we want to do for each of these is we want to look at the category and we want to find that student's average. And it is going to take us quite a bit for the exams. So starting with the homework category, this student scored 140 out of 210 on their homework. So if we plug that into our calculator, that will give us 140 divided by 210. Oh, backspace 10. That gives us about 0.667. Okay. So we'll leave that as is for right now. I'm going to need that calculator though. So just to give you an idea for this, this is a 66.7% they scored on their homework. Now when it comes time to the exams, that's a bit more complicated because we have 5 exams in total. On the first exam, they scored 64 out of 100 points. The second exam is 81 out of 100. The third exam is 77 out of 100. Fourth is 42 out of 100. And then that fifth exam is 73 out of 100. So really what I want to do, the exams overall count for 60% of my score. We need to find the average of this. So I really need to add all of these together and then divide by how many exams I took, which is 5. Okay. Now, realistically, what we can do is we can add the stuff in the numerator because they have all the same denominators. So really, we're just going to go through and add those tops. So if I do 64 plus 81 plus 77 plus, didn't take my 7, 77 plus 42 plus 73. That gives us 337. You can extend that. That gives us 337. The denominator stays untouched in the top. And then we will divide that by 5. So if I take 337 and divide it by 100, and then I take that and I divide it by 5, we see that we had an average of 0.674, which means we scored an average of 67.4% on our homework. Okay. So that is our exam category. Then the last is the final. And in that case, we scored 65 out of 100, which really is just a straight 65%. If you divide the two, it's 0.65 or 65%. Okay. Now what we're going to do is we're going to take the weights of each of these and multiply it by their average in that category. So their homework average was 66.7% out of a possible 100%. So we need to find 15% of that. Same thing, their exam average is 67.4%. we're going to find 60% of that to see how much they scored in their exam category. And then we do the same exact thing with the final. We take the 65% and it's worth 25% of the grade, so we times it by 0.25. So in each of these instances, we're going to look at the category, their average, the weight in that category, and then we're going to figure out how many points out of that amount they earned. Okay, so for homework, their average was 66.7%. And the weight for this category is 15%. For exams, their average was 67.4%. And the weight for this category is 60%. And then finally, we have the final. They scored a 65%. It is worth 25% of their overall grade. Okay. So what we're going to do is we're going to figure out if this was 100%, you would times it by 0.15. There is a possible 15 points for the homework category in their overall grade. There's a possible 60 points for the exam category and 25 points for the final. So we take each of these averages and we figure out what is 15%, 60%, and 25% of it. So really you're going to have to use the decimal form for each of these. So this is 0.15, this is 0.60, and this is 0.25. So I take their average, which is 66.7% in homework, and we times that by 0.15. So if I take 66.7 and I find 15% of that, they earn 10.005 points out of 15 possible points. For exams, they scored 67.4%, and it's worth 60%. So if I take 67.4 and I times that by 60%, this gives us 40.44. So they earned 40.44 out of 60 points for the exam category. And then for the final, we take 65 and we times that by 0.25. And that gives us 16.25. So they earned 16.25 points out of a possible 25. So their ultimate overall grade is we add these together. It's the points from the homework category, which is 10.005, the points they earn from exams, which is 40.44, and then the points from the final, which is 16.25. So if I add these together, that gives us 66.695. But it's a grade, we're only rounding to 1 decimal. So if I'm rounding to 1 decimal, I look at what the next number is. That's a 9, that tells me to bump up the 6. So their average was 66.7%, okay? So this is what you would do to calculate your grade in any of your courses. You might have to find averages within, and your GPA is worked in a very similar manner. It just depends on the number of credits and the actual grade that you get in the course.